In our lesson today, we're going to have an introduction to rates and unit rates. And to help us investigate rates and unit rates, we're going to look at three different turtles here. Three teams train turtles for the third annual turtle trot, which is a 30-foot race. If the turtles trot at their training pace, which turtle will win the race, and by how many minutes? And explain your reasoning. And so we've got our three teams here, and we can see their training paces. Team 1 turtle can go 18 feet in 6 minutes. Team 2 turtle can go 16 feet in 8 minutes. And Team 3 turtle can go 10 feet in 2 minutes. And we want to know which one of these turtles is going to win the race. And we have to remember back up here that it's a 30-foot race. So we're going to have to figure out which of these turtles can go 30 feet in the shortest amount of time. And in order to do that, what we're going to want to do is try to figure out what their speed is, also known as their rate. Okay, a rate is a ratio. A rate is a ratio. Let me get my lead working here. A ratio that compares quantities measured in different units. Okay, we can see that we're going to be working with a rate here because we're trying to figure out how many feet they can go in a certain number of minutes. So we're comparing two different types of units here. Okay, what we're going to want to do is try to figure out each turtle's unit rate. A unit rate is the rate for 1 unit of a given quantity. When a unit rate is written as a fraction, the denominator is going to be just 1 unit. And the 1 in a unit rate is read as the word per. You've probably heard rates that use the word per, like miles per hour or feet per minute, something like that. And in fact, that's what we're going to be looking at in this example. We want to know how many feet can the turtles go in 1 minute. So we want to know their feet per minute. In order to find unit rates, we will use ratio tables. We're going to use ratio tables a lot in this topic to help us find unit rates. Ratio tables look like these items down here. They may look familiar to you from 6th grade. Okay. Once we know our unit rate, we can then use the unit rate to scale ahead to solve some problems. And that's what we're going to do in this example right here. In each of the ratio tables underneath, I've put the training paces. Team 1 turtle, we said, can go 18 feet in 6 minutes. Team 2 turtle can go 16 feet in 8 minutes. Team 3 turtle can go 10 feet in 2 minutes. And we're interested in finding the unit rate for each one of these turtles, which means how many feet they can go in 1 minute. So for the minute section for each of these turtles, in the next open box, I'm going to put 1. We want to know how far can they go in just 1 minute. Well, in order for Team 1 turtle to go from 6 minutes to 1 minute, we're going to have to take that and divide by 6. 6 divided by 6 equals 1. Since I divided the number of minutes by 6 to get my 1 minute, I'm going to do the same thing to my number of feet. Divided by 6. 18 feet divided by 6 is equal to 3, which means that this turtle can go 3 feet in 1 minute. For Team 2 turtle, okay, they can go 16 feet in 8 minutes, but we want to know how far they can go in just 1 minute. So we're going to do 8 minutes divided by 8 to get our 1 minute. Then we'll take our 16 feet and divide it by 8. And 16 divided by 8 is 2. So this turtle can go 2 feet in 1 minute. And now for Team 3 turtle, they go 10 feet in 2 minutes. We want to divide by 2. 2 divided by 2 to get us to our 1 minute. And now we'll do the same thing to the number of feet. 10 divided by 2 is 5. So this turtle can go 5 feet in 1 minute. So now that we know what each unit rate is for our turtles, we can then scale ahead to figure out how long it's going to take them to go a distance of 30 feet. Remember back up here, we were told that it's a 30-foot race. So the next thing I'm going to do in my tables underneath, in the number of feet, in the next open spot, I'm going to put 30, because the turtles have to travel 30 feet in the race. So now we're going to scale ahead to figure out how many minutes it's going to take each turtle to do that. For Team 1 turtle to go from 3 to 30, you're going to have to multiply by 10. So we'll do the same thing to our number of feet. 1 times 10. This turtle's going to take 10 minutes to run the race. For Team 2 turtle to go from 2 to 30, we're going to have to multiply by 15. We'll do the same thing to the number of minutes. 1 times 15 is 15. So this turtle is going to take 15 minutes. And then for team 3 turtle, to go from 5 to 30, we'll have to multiply by 6. Do the same thing to your number of minutes. 1 times 6 is 6. Team 3 turtle's going to take 6 minutes to run the race. Since we know that team 3 took the shortest amount of time, we can answer our question up above. Which turtle will win the race? Team number 3 wins the race. And then it says by how many minutes? Well, it's going to win by, we've got to find out who the second place turtle was. That would be team 1, since they finished in 10 minutes, by 4 minutes over team number 1. Team 3 turtle took 6 minutes. Team 1 turtle took 10 minutes, so they were 4 minutes faster than team number 1 turtle. In the next section, we're going to compare ratios and rates. A ratio is a comparison of two similar objects or quantities. For example, all right, we have 18 boys and 15 girls. Boys and girls, they're all part of a bigger group. So I look at my table right here, 18 boys, 15 girls. Well, I would call them all students. In all my classes, I have boys and girls, so they're all students. And if I were to add up how many students I had in my class, I would have a total of 33 students. What I want to do is give the ratios of boys to students and girls to students, but I always want my ratios to be in simplest form. So I'm looking at all my numbers here, 18, 15, and 33, and I'm looking for a common factor that they share. All three of these numbers are divisible by 3, and so that's what I'm going to do to all of these numbers. I'm going to divide them all by 3. Divide that one by 3 as well. 18 divided by 3 is 6. 15 divided by 3 is 5. 33 divided by 3 is 11, and I can check 6 plus 5 makes 11. So if I wanted to give the ratio of boys to students in simplest form, well, boys in simplest form was 6, students in simplest form was 11. I could write that as a fraction, 6 to 11, or I could write it 6 colon 11 like that. For girls to students, again in simplest form, girls was 5, students was 11. I could write the ratio 5 over 11 like so, or 5 colon 11 like that. So a ratio compares two similar objects or quantities. A rate, however, compares two objects or quantities that are not similar, like what we were just doing with the turtles. In the second example, it says that we can go 220 miles in 8 hours. Well, miles and hours are not similar quantities. We want to calculate the unit rate in miles per hour. So what we want to do is figure out how far could we go in just 1 hour. Well, to go from 8 hours to 1 hour, we're going to have to divide by 8, which means I'm going to do the same thing to my number of miles. Take 220 and divide by 8. And if I did that, I would get an answer of 27 and 5/10, or 27.5. This means that the unit rate is 27.5 miles per hour. That slash that I wrote right there is the word per. We could also write it 27.5 miles per hour. That's the accepted abbreviation for miles per hour. In question 3 and question 4, I'm going to have you calculate the unit rates in each of those examples. In 3A, we wanted to calculate the miles per gallon, so how far they can go with 1 gallon. Well, 15 divided by 15 gets us to our 1 gallon. We do the same thing to our miles. 120 divided by 15 equals 8, and that makes the unit rate 8 miles per gallon. Make sure that you include the units on there, and also make sure that you show in your ratio table how you're coming up with that unit rate. In example B, we can go 100 meters in 16 seconds. We want to figure out how many meters per second we can travel, so we need to figure out for 1 second. 16 divided by 16 equals 1, so we'll do the same thing to our meters. 100 divided by 16 is 6 and 25 hundredths, so the unit rate is 6 and 25 hundredths meters per second. In example C, we can go 90 kilometers in 1.5 hours. We want the number of kilometers per hour. So 1.5 divided by 1.5 gets us to our 1 hour. 90 divided by 1.5 gets us to 60, so the unit rate here is 60 kilometers per hour. In example 4, we were told that the lobster molts 20 times in 5 years, so we put 20 molts in 5 years. We want to know how many times per year that the lobster molts, so we would want to know how many molts in 1 year. So 5 divided by 5 gets us to our 1 year. 20 divided by 5 is 4. This means that the lobster molts 4 times per year, 4 molts per year. Now that we've practiced finding unit rates, we're going to use the unit rate to help us solve some problems. In example 5, Ben can type 153 words in 3 minutes. At this rate, how many words can he type in 10 minutes? Well, before we can figure out how many words he can type in 10 minutes, we should figure out the unit rate, how many words he can type per minute. So I want to know in 1 minute, how many words can he type? So to go from 3 minutes to 1 minute, I'm going to divide by 3. Do the same thing to your words. Divide by 3. 153 divided by 3 is 51. So this means that Ben can type 51 words per minute. That's the unit rate, 51 words per minute. We want to know how many words can he type in 10 minutes. So we're going to scale ahead now from 1 minute to 10 minutes by multiplying by 10. Do the same thing to your words. 51 times 10 is 510. And so we can say Ben can type 510 words, 510 words in 10 minutes. Okay, so the key to doing these problems is finding the unit rate first and then scaling ahead to answer the problem. In example 6, Ken buys 3 yards of fabric for $7.47. He then realizes he needs 2 extra yards. We need to figure out how much those 2 extra yards will cost. So let's figure out the cost of 1 yard first. $7.47 for 3 yards. We need the cost of 1 yard, so we'll divide by 3. Do the same thing to your dollars, which gets us to $2.49 per yard. Now we're going to buy 2 extra yards, so we'll go from 1 yard to 2 by multiplying by 2. $2.49 times 2 is $4.98. So 2 extra yards of fabric will cost $4.98. In example 7, we're told that an astronaut's diet contains 18 milligrams of iron for 2 days. We need to figure out how many milligrams he would need for 9 days. So we know 18 milligrams of iron in 2 days. Let's figure out how many milligrams of iron per day. To go from 2 days to 1 day, divide by 2. Do the same thing to your milligrams. 18 divided by 2 is 9. So an astronaut should get 9 grams of iron per day. Since we need to know how many grams of iron or milligrams for 9 days, we're going to do 1 times 9 to get us to our 9 days. 9 times 9 gets us to 81. So an astronaut's diet should contain 81 milligrams of iron for 9 days. In our last problem, we're told that a satellite travels 2,272 miles in 8 minutes. We want to know how far the satellite could travel in 3 minutes. So we start by filling in what we were given, 2,272 miles in 8 minutes. To find the unit rate, how many miles it could go in 1 minute, we're going to do 8 divided by 8 to get us to our minute. 2,272 divided by 8 is 284. So the satellite can travel 284 miles per minute. Now we want to know for 3 minutes how far it can go. 1 times 3 gets us to our 3 minutes. 284 times 3 is 852. This means that the satellite travels 852 miles in 3 minutes.